Question 7 is a buffer question. We're looking for the pH of a buffer containing citric acid and sodium citrate. As we've said many times, anytime we're dealing with a buffer question, we need our Henderson-Hasselbalch equation. pH equals pKa plus log of the base over the acid. So there's three separate things that we're going to have to calculate here. The pKa, the concentration of the base, and the concentration of the acid. The pKa can be calculated as the negative log of the Ka. And the Ka is given to us in the problem, 7.4 times 10 to the minus fourth. We take the negative log of that, we get 3.13. We can fill that in as the first term in our equation here. From here, we need to now calculate the concentrations of both the acid and the base. As we've seen many times before, we need to know which one is the acid and which one is the base. This is a pretty straightforward example because the acid is the one that has acid in its name. It's also the one that we have a Ka value for. So I'm going to start with the citric acid and find its concentration, 100.00 grams. We know that the molar mass, or we can calculate the molar mass of citric acid, and that's 192 grams. So again, we're looking at HA here. So this allows us to calculate the number of moles. Upon doing that calculation, we find we have 0.52083 moles. Now to find the concentration, we just need to divide this by the volume of 1.03 liters. And that tells us our concentration of acid is 0.505 molar. So we can now plug that in our equation for HA. We now need to do the same thing for A minus. We also have 100 grams of sodium citrate. The molar mass of sodium citrate, again, we can calculate that from the chemical formula, 214 grams. And we get 0.467 moles. We can divide that by the volume, 1.03 liters, and we get a concentration of 0.454 molar. Again, we can plug that into the Henderson-Hasselbalch equation. We can do our calculations, and we get a final answer here that the pH is 3.08.